A classic application of timers is for stoplights. If you have an intersection with several different signals, those signals need to be timed. And really, timing is the main way that the lights change. They go from, of course, red to then green to yellow and then back to red. But it's based on time. Now, of course, in more advanced intersections, there are sensors for sensing whether a car is in place or not. There are turning lanes. There are crosswalks for pedestrians. But I've created a simple timing, or rather traffic simulator in Factory I/O. And it's pretty straightforward. It consists of some conveyors that represent the lanes that cars can travel through. And you'll notice there are some stack lights here. I'll zoom in on it a bit so you can see them. So there's a stack light that has the typical red, yellow, and green lights. And I've placed those around where you can see them. I'll go to an overhead view. Go to an overhead view and zoom out just a little bit. You can see the traffic layout. So certainly you can see I guess I can rotate this around. You can see a left to right and right to left conveyor system. So just like we're in the United States, so we drive on the right side of the road. So on the horizontal two conveyors, the lower one would be going to the right and the upper one would be going to the left. And then, of course, there's the vertical conveyors moving up and down, and they're not vertical in the simulation, it's just in this view. And then the one on the left, of course, would be moving down the screen, and the one on the right is moving up. To make all of this work, I had to put some rotating tables in the middle of the intersection in order to rotate around and allow traffic to actually pass through on the various lanes. And all of that is set up automatically. You don't have to worry about making this function. All you need to do is write code to drive the lamps. There's a lamp at each direction. So there's 4 signals and 3 lamps on each signal. Now I'll go ahead and show you some of the details of the code that makes the roadway work. I've made a subroutine here. I tried to get it out of the main program so you wouldn't have to worry about it. So you will have this program to start with. And there's just an unconditional call to the subroutine from the very beginning. I'll go ahead and double click on the traffic subroutine, or traffic simulator subroutine, and step you through it quickly to tell you how it works. There's a start and stop button. They are over on the panel. If I rotate around a little bit, I can show you the panel. Let's see, we'll move over, rotate down, maybe not quite that far, rotate around, move over a little bit, and then if we rotate around a little more we can zoom in. And let's see if I can get it into a better view. There we are. So it's the typical start-stop button with a reset. Now I'll explain what the reset is for in a moment, but I did set up the reset button for you to use. So to get the traffic to start flowing, to turn on the conveyors and things, you have to press the start button. Of course, it helps if the simulator is running. There are quite a few I/O here. Most of them you really don't care about. I'll go ahead and show you some of them. Show you the ones you care about and the ones you don't. All you really care about are outputs. In fact, the only outputs you care about are all of the light outputs: red, yellow, green, red, yellow, green, red, yellow, green, and again for traffic signal 1, 2, 3, and 4. And they're labeled that way. The roller conveyors, and if you scroll down, all of the other outputs for the turntables and the other conveyors, you don't have to worry about. All of this is taken care of when you turn on, when you press the start button. The only outputs you need to drive are the light outputs for the various lamps. You also don't have to worry about inputs. I'm using these to make sure that everything works, and the traffic simulator I've made here is not perfect, but hopefully it will function well enough for you to get through a few cycles of traffic going through the intersection. So let me go back to an overhead view and show you how this thing works. traffic or the start-stop button indicates the number 1 side. So if you go down and you look at the way that the stack is labeled, it's not clear which one's which right now because I've turned off the symbols, but let me go down just a little bit and we'll zoom in. Let's see, there we are. We'll move forward and then perhaps zoom in a bit. Okay, so this light stack here, this traffic signal, you might wonder which one is it? Well, it's number 1 because it's the one beside of the control panel going forward. But let me show you how you can tell. If you go to View and then say Show Actuator Tags, well, then you can see the tags that are associated with that particular output set. So stack light 1 red is this red lamp here at the top. Stack light 1 yellow is the yellow light, and stack light 1 green is here. Now, the way I numbered these is really important to understand because you have to know which ones you're driving. So the signals you can see going this way into the view, of course we've seen one. The one across from it is I labeled it too, and we can go and look at it. So if we zoom in on that stack light or that traffic signal from the back side, then you can see that it is traffic signal 2. I continued naming this way, and the one over on the right here, to the right of number 1, is 3, and the one across the way on the opposite side, and we'll move over there, that one is 4, and you can see it. So again, I'll go to an overhead view and I'll call out the numbers so that it's clear. So let's see if we kind of get centered over everything and then zoom out enough. On the left side we have number 1, on the right side is number 2. Of course, I'm talking about the entering conveyors where you have a green arrow coming in. And then at the bottom of the screen on the right we would have conveyor 3 and light stack set 3. You don't really care about the conveyor numbers. But then coming down from the top on the left side we'd have light stack or traffic signal number 4. And of course, like I said, you can always tell which light stack is number 1 because it's the one closest to the control box, the start-stop box. Now, there's a lot to drive this and make it work. The emitters are forced, the removers are forced. You can see that if you choose View and then Dock All Tags. You can see which in the simulator I have forced. And that's just so that they will automatically put pallets with boxes on them to simulate cars onto the conveyors. And you can look through these if you want, but most of what you need, in fact all of what you need, are all the outputs that are the lamps, all the stack lights. So stack light 1, 2, 3, red, green, and yellow are the ones you care about. So let me clear these docked tags. Now let me show you how the kind of the behind the scenes work in order to make this traffic simulator go. So you as the user will press the start button, that will turn on a lamp, and if you press the stop button that turns on the stop lamp, and of course turns off the start lamp and vice versa with start. And then what I have to do, because the PLC is blind, so the PLC has no idea what's really going on, so what I've got is every time a pallet enters the center area, it's counted, and then when it leaves, it's subtracted from the count. So I've got count 1 that goes with conveyor 1, which was on the left in our overhead view, count 2, which is on the right in the overhead view, count 3 for the conveyor at the bottom going up, and count 4 for the conveyor coming down. Now the conditions here that I've got have to do with sensors that are on the rotating tables, what position the rotating tables have to be in, because the tables serve more than one direction, right? They have to turn 90 degrees and serve 2 different directions. So I don't really want to count a car as going into the intersection from a vertical direction when it actually came in horizontally. So you don't have to worry about that, but that's basically how this works. And then I'm actually looking for a falling edge on a sensor at the exit, coming out of the lane, going onto the exiting conveyor, regardless of which one it is. And so you'll see that all of these counters are set up pretty much the same way. You don't have to understand exactly how these work or what they do. The whole point of the counters is so that I don't allow traffic to drive in when you give me a green signal if there's already, you know, if the rotating tables aren't set up in the right way so that traffic can get across, right? Because if they're at 90 degrees, there's a stop there. There's a mechanical stop, and the pallets just run into it and won't go anywhere. And you'll see plenty of this as you try to program, I'm sure. I use the start button light as something to just turn off a few things. I don't want anything to run essentially in the real world or in the simulated world. I don't want anything to turn and move mechanically if the start button is not on, if the start button has not been pressed, in other words. So the start button light is what I use to block a lot of things. And again, you don't have to worry about why. Basically, the intersections need to be clear before turntables can turn, and that's really what this instruction says. The count value has to be 0 before we can turn any of the tables. Now there's some other conditions, like for example with the lamp. So you have to stick with the numbers that I've given you on the traffic signals, otherwise this part won't work, because my programming depends on your lights, and when those lights are on, that's when it decides that, hey, if the green light's on in one direction, I should probably orient the rotating table so that traffic can get through. Now if there's already something on those tables, then we need to let it complete wherever it's going and leave, in other words, the count to go to 0 before we rotate the tables and service that direction. Similarly, the conveyors that come in allow me to control whether or not cars move forward, right? They're at the intersection, they're looking at the light that you've programmed, they see a red light so they don't go. How do they not go? Well, I don't let them go. And when do I let them go? Well, we've got to be in run mode for one thing. The count has to be 0. In other words, there has to be a clear way through the intersection. The green light has to be on, or maybe in fact there may be more conditions here. What else have I got? Yeah, the table has to be in the right orientation, both do, before we can go. Or, instead of all this, if lane 1 in is not true. Now what does that mean? Well, if you think about it, at the very beginning of the program I have to somehow get pallets or cars up to the point where they're stopped at the red light. So basically there's a sensor that goes across each of the inlet conveyors, and if the sensor's not tripped, that means that there's nothing ready. There's nothing waiting at the stoplight. So by default I allow pallets to move forward or cars to move forward until they are in position, you know, waiting for the light to change. Now that position's a little bit behind the light, admittedly. My lights are, these people like to go through, they like to sit beyond the red light, so a little bit odd, but it was the best I could do here to make it look decent and make it work. So that's how basically all the turntables and conveyors are driven. And then the last thing to mention is what the reset button does. Now in this simulator it's certainly possible that, you know, a pallet or a car will end up in the intersection, get stuck for whatever reason. Maybe it comes in kind of cockeyed. Sometimes what will happen is two pallets will butt up together, come through, and so since I'm looking for a falling edge at the exit I might miscount, you see, because, you know, as one goes through, they were both sensed as coming in, but now they've butted together in the intersection, and so when one leaves, the other one that's right behind it, well, you don't see a falling edge when the first one leaves because the next one behind it maintains the sensor. And so even though two have gone out, my programming can't tell the difference between that and one going out. And so it thinks that there's still a pallet or car in the intersection, so it won't turn the turntables to service the other direction. So being able to reset these counters is really important for you in your troubleshooting and simulating. And so that's why I've included a copy command. Now all this really does is it resets all the counters to 0. So it's I'll demonstrate this along the way, but when you have pallets anywhere, you can actually grab them while it's being simulated and just move them off the conveyor if you want, throw them on the floor. But then you've changed the count, or if the count has been changed by any method, you really need to hit the reset button. So on that control panel there was start and stop. Reset is really important because basically my program is blind. It can't see what's really going on. And it's fairly common for it to get confused because of pallets butting up together or something going wrong in the intersection, which does happen. Unfortunately, I don't have a way to, or I haven't figured out a way to make it any better yet. Now I do make the light come on when you press it. And then finally, the start button light, all that does is that turns on the roller conveyors in the center so that the rollers are turning, and it turns on all of the exiting conveyors. And that's one of the reasons you have to hit the start button to get this thing going. There's no reason to not have all of those on continuously. Now the inlet conveyors that are before the lights, those certainly I need to be able to turn off when the light's red. And so that's, as you've seen, what I've got here. So your challenge is to write the main program. Now, since you guys are beginning, I'm going to show you one way of doing it. There's many ways of doing this, but I'm going to do it using 4 different timers. So let's start off, and basically what I'm going to do is set up some timers, and I guess I'll just use timer 1. Let's say seconds, and we'll start off with let's say we start off with the red light. We'll turn the red light on for 30 seconds. Now I'm not really turning on a light yet. So far all I've got is a timer that without any conditions just starts running when the PLC turns on. Now the nice thing about it is that its output will not come on until 30 seconds after it is run. But let's give this a name. Let's edit the run comment. We will call this the red 1 timer. So this is going to be for stack light 1, the red lamp, and it'll time it for 30 seconds. Now, obviously it's not actually doing anything yet. It hasn't turned the red light on yet. Okay, so why don't I do this? Why don't I put a output? Let's see, like I said, I'm going to use 4 timers, so there's 1, 2, 3, 4. I'll leave those open. I'll move it. Well, I thought I'd move it down there. I don't know what it's upset about. It'll only let me put it in certain places. Okay. So I want the red lamp 1. I've already named these for you so you don't have to do that. But Y001 is the output to drive red light 1. So I'll say OK. Okay, so there we go. And let me see if it'll let me insert a couple of rows because, let's see, insert, that's not what I wanted. Insert rung before cursor. There we go. And do it again. Okay, now it's where I want it to be. But there's no conditions. Now the red light would just be on. So when does the red light need to be on? Well, if this timer starts running, it's whenever the timer's done that the red light needs to shut off. So if the timer is not done, the red light needs to be on. The way I would say that is look at timer 1, and if it's not true, if it's not done in other words, turn on red lamp 1. Okay. Well, after red, what comes next? Well, it's not yellow, even though if you go down, that's the way the traffic lights go up from bottom. Green, yellow, red, green, yellow, red. I happen to start at red. It doesn't really matter where you start, as long as you go in the right order. I need another timer now, timer 2. This timer is going to time the light that comes after red, which is green. So I'm going to let it run, let's see, let's change to seconds. I guess I'll let it run for 25 seconds. And if I'm going to let a timer run, maybe I should name it for one thing so I know what it's doing. Edit run comment. This will be green 1 timer. And you might say, well, that looks good because it'll happen after the red timer. Well, actually, the way I've got this written, it won't, because remember that PLCs do not just stop on a timer until it's finished running. They go on to the next rung. So actually, these 2 timers will begin at essentially the exact same moment. I don't want that. I want the green timer to be cascaded. In other words, I want it to happen after timer 1 is done. So all I have to do is put a set of contacts in here saying that when timer 1 is done, when that is true, then run this next timer. Okay. Well, it's nice to have a green timer, but the whole point of the timer is to have a green light. Now, when should the green light be on? Well, first of all, let's get the green light. So green 1. When should the green lamp in direction 1 be on? Well, it should be on when timer 1 is done. Okay, that makes sense. So after timer 1, because timer 1 is the red light timer, and when timer 2 is not done, right? So when the green timer is not done. Now you might look at this and say, well, wait a second. wouldn't have been easier just to say green should be on when red is not? I mean, couldn't you have used a Y here, Y1? You could, but remember there are other times that green is not on and red is not on, right? Think about when yellow is on. When yellow lamp is on, the green lamp can't be on. So, I mean, you could say, you know, when the red lamp's not on and the yellow's not on, the green should be on. But the problem is, what people, well, here, I'll show you what that would look like. What students tend to do is they make this mistake, and it's a pretty straightforward mistake. They say, well, let's see, when red 1 is not on, and when you can probably guess that the address for yellow is Y2. When it's not on, when yellow 1's not on, and red's not on, then green should be on. And, well, let's see, red should be on. Forget all this timer stuff. Red should be on when yellow is not on and green is not on. So we can just do this, and this will make our lives easy. Yellow, or actually not yellow, but when green is not on. And what you hopefully realize is we'll end up with some circular logic, because if we do the same thing here and say, okay, the yellow lamp should be on when the other two are not, there's nothing to drive this with time, right? It's just they all depend on each other, and basically what would happen is they would just flash on and off. In fact, they would flash so fast in the real world they would look like they're all on, because they're all turning on and off very rapidly, and you might break something in the real world. No, this has to be timer based, right? So in fact, I'm going to make my life easy and go back to before I made such a big mistake. It's often a mistake to drive outputs based on the status of other outputs. You can end up with a circular reference. You remember Excel, when you were learning Excel and you typed a formula in one equation and depended on a variable in another cell, and that variable depended on the first equation? Well, Excel would always give you a circular reference warning. PLC programs or software won't give you that warning. They'll just do whatever they can to be consistent with the logic, which will not be what you want, I guarantee. So it's better to think through this and make sure it makes sense. If timer 1 is the timer for the red lamp, then just when it's not done, the red lamp should be on. Similarly, when the red lamp or red lamp timer is done and the green lamp timer is not done, the green lamp should be on. So basically, the green lamp is on during timing. Now, Allen Bradley and Rockwell have several different bits associated with their timer, whereas this Click Koyo only has the done bit, essentially. But that's what it would be called in Allen Bradley. Allen Bradley has a timer timing bit, a done bit, and an enable bit. It's a little bit excessive. There's ways to get around all of that, and there's nothing missing here in this programming language. You just have to think of the logic a little bit differently. So there's red 1, green 1, and I had pulled in a yellow 1, but I backed out of it. So there's yellow 1. When should yellow 1 be on? Well, we don't have a yellow timer yet. Why don't we throw one in? Okay, so this will have to be timer 3. Notice I have to use a new timer number each time. Seconds, we'll let it run for 5 seconds. And let's name this, edit the run comment, yellow 1 timer. When should it run? Well, as soon as green's done, right? As soon as the green timer is done, then the yellow timer should run. You know, I probably should try to name these. Let me give it a shot. We go to the timer bits. I should be able to name T1 red, let's say 1 timer, and then 2 is actually the green timer. That unfortunately does not match my output numbers, but that's okay. Green 1 timer. And then finally, yellow 1 timer. Go back to pickup mode. And I was interested in T2, so I'll grab that. There we go. So now they're labeled at least, and I guess I don't need the run comments. And this makes more sense. So let's just delete the rung comments. I don't have good rung comments right now anyway. Maybe a better rung comment would be that this timer doesn't really make the lights come on. That might be a better comment. Okay, let's get rid of the rung comment here. There we are. So there we have 3 timers, and let's get rid of this extra rung. 3 timers that drive 3 lamps. Well, almost. Yellow 1 is just on all the time. When should yellow 1 be on? Well, you could say, well, it should be on when red and green are not on. And that would work. But it'd be what I call dirty programming. It's not consistent with the rest of the program, and I promise you can cause trouble later, especially when you're a beginning programmer. The better thing to do is to realize, well, yellow should be on once the green timer is done, right? It's that simple. So once the green timer is done, T2, yellow should be on. Now you might look at this and say, well, wait a second. This makes sense. I mean, when the red timer is not done, the red lamp comes on. When the red timer is done but the green timer is not, the green lamp comes on. And when the green timer is done, the yellow lamp comes on. But don't we have to wrap back around? We do. In fact, I've set this up in a particular way. Notice that once these timers are done, they just stop, right? We'll only get one cycle, red, green, and then yellow, and that's it. We need to go back to red. How do we do that? There's a very easy way. What I'm going to do is put in a set of inverting contacts on the output of timer 3. Because what this says is when the yellow timer, which is all the way down here, is not done, then this one can run, you see? Now notice the PLC will go through and will jump onto line 4 very quickly, and the yellow timer won't be running, and so it'll go down and continue to evaluate what the lamps should be doing. And then it'll come back up, and eventually timer 1 will be done. Now ultimately what will happen is these timers being cascaded on each other are kind of like a house of cards. Once the yellow timer is done, well, then T3 will be true. The inverse of true is false. These are not retentive timers, and therefore that will shut off this timer. Will reset it. So it'll start counting again. It won't be done anymore. That will make timer 2 fall. It won't be done anymore, and that'll make timer 3 fall. So they'll all start over on their own. And then the lights will be driven based on this. So since we've got a little bit of programming done, let's just see if this works. I mean, after all, it doesn't really matter if it's in start mode or not. We should be able to download this to the PLC and watch a signal lamp go through its cycles. So let's give it a shot. Hopefully I don't have any bugs in my program. Well, it looks like it'll compile okay. Go to run mode. And now let's go over to the simulator and let the simulator run so the PLC can make things happen. Now it was signal number 1, so let me go around to signal 1 or direction 1 and have a look at it. I think I see a red light. Yep, we've got a red light. We've got 24 seconds on the clock, 27, 28, 29. It should change to green. It did. Let's go down. Whoop, let's go down a bit. Green should last for 25 seconds. We're at 11 right now. Notice none of the other lamps are doing anything, which we haven't made them do anything yet. 24, 25, there's yellow for 5 seconds, and there we are, we're back to red. So as soon as the yellow timer was done, that made all the timers fall, and the red lamp came on. Now, once, the cycle just continues over and over, and I didn't see the red lamp on with the yellow lamp or green, so that was good. Well, that's nice, but the other traffic signal over there, let's see, which one is it? Traffic signal number 2, I believe. Yeah, traffic signal number 2 needs to just mirror traffic signal number 1. This is not a complicated intersection. So why don't we add that in while we're here. let's see, I will add some wire connections so that I can add some outputs. And these outputs will be the other direction. So red 2, for example, would be on, I believe, Y4. Yeah, if you don't know what they are, it's okay. You can look it up. When you drop your output, all you have to do is click on the 3 dots and then select the one you want. So green 2 is the next one. But they're just separated by 3 addresses, so it's easy enough. Here we are. And so this is yellow 2 that I need, so 2 plus 3 is 5, so Y5 should be the proper address. There we go. Well, I always recommend when you're programming that you often download and test your program just to make sure that it works properly. So I've made a small change, it's nothing big, but I want to make sure that it makes sense, that it works, that it does what I expect. Because if I, make a whole bunch of rungs without testing along the way, I can't guarantee that anything has worked along the way, right? So it's always wise to check your work. We're at 14 seconds. Another thing that's really important, it's always very wise to save different iterations of your code. You notice I haven't saved so far. I should. I've actually already lost work today when my connection to the remote machine went down. Okay, looks like light stack 2 works. We've got a green lamp, which would make sense after red. And notice that the current value of the red timer just keeps going, and that's okay, it doesn't really matter. Some PLCs will stop their timers after they've reached the set point, but not this. So let's see, yellow, there we go, good. 5 seconds, and we should go back to red, and we do. Okay, that's nice, but that's not both directions. I'd like to drive the other direction as well. I mean, after all, that's nice that 2 of these work, but what about the other direction? What about, let's see. My motion has to be a little clunky because I'm using this navigation tool. Unfortunately, my right mouse click does not work over remote access, so I'm stuck with it as it is. So here's stack light 3. What about stack light 3 and 4? What should I do with those? Well, you might look at this and say, why don't we make one side the master side and the other side the slave side? So side 1 and 2 would be the master side that has the timers driving it. The other side, it might not be so bad to drive them based on the other outputs. So I'm going to do this, driving the outputs on the slave side based on the outputs from the master side, and we'll see what happens. So we'll see if I get confused or not. Probably not, but it's easy to do. So let me go ahead and just drop in the addresses that I want to deal with. As a matter of fact, I'm going to be lazy. Actually, I'm going to be efficient. I'm going to copy the structure of each of these and then paste them, because I think copying the structure will be much faster. Now, obviously, I don't want to reuse the same addresses, and the logic will be different, but I'm just trying to avoid doing all the work on the right-hand side. Let's see, last one here, copy, and we'll paste it. Now, another reason for doing this is so I don't forget to put my end statement in here. But I don't want these to try to drive the other directions. These are supposed to drive or redrive the same direction. I want them to drive the other direction. So let me see. Red 1. Let's see. It's on address 1. I actually want that to be red 3. So that's address 7. So I have to add 6. I think the rule will be just to add 6 to everything. Let's try that. So instead of 4, I'll put in 10. So that's red 4. Red 3, red 4 go together. That makes sense. So the rule was add 6. So 3 and 6 are 9. Green 3 is what I wanted. Good. I want green 4. So add 6. That's 12. Green 4. It's always nice to set up your inputs and outputs with some logical, predictable pattern where the numbers match, where things make sense. one of the things I probably should have done is I probably should have put these in order as they appear on the stack light: red, yellow, green. I didn't set it up that way, but you know, it's not the end of the world. It's just maybe not optimal. Let's see, 6 and 2 are 8. So there's yellow 3. 6 and 5 are 11. So there we are. Okay. Now, like I said, the conditions are very different. I need these branches. That's the reason I did the copy in the first place. But if you think about red in the alternate directions, well, red should always be on if either green or yellow are on. So I'm going to set it up that way. Instead of basing the red direction on timers, I'm just going to base it on either yellow or green. So what I'll need is another branch, and then what I will do is say, well, if green in the other direction, I'm going to refer to Y3 because it's direction 1, it's the one I began with. Or if green 1 is, well, no, I've already got green 1. If yellow 1 is on, and yellow 1 is Y2, well, then the red lamp in the cross direction should be on. I mean, that makes sense. You can't have green or yellow on in one direction and then not have red in the other. You're going to cause a wreck. So that makes sense. Green or yellow should drive both reds on. But that won't work very well for green, because if you think about it, what happens is when red is on in the other direction, green needs to be on initially, but then it needs to shut off for 5 seconds for yellow to turn on. So I don't actually have a timer to time this lamp. You might look at it and say, well, don't you already have a green timer? I mean, after all, it's right there. I have, but this timer is already running at a different portion of time, and I would rather not reuse it. It would make the logic very difficult and complicated, and there's no need. I've got plenty of timers, so I guess I should have kept that other rung that I deleted. I think I deleted a rung. That wasn't my intention. I wanted to insert a rung. Insert rung before. There we go. That's right, because I said I wanted 4 timers, and then I promptly deleted the row for the other timer. So timer 4, I'm going to make this one run for 25 seconds. Now, what would be the condition for this? Well, it's helpful to draw a timing diagram, but I didn't think to do that before I started this video. If you think about it, what happens? Well, in the real world, there's some overlap between red, right? Have you ever noticed that at traffic signals, the cross direction in your direction will be red at the same time for some small period of time? I'm not going to do this. What I'm going to do is have red on one direction come on right when green in the cross direction comes on. And I won't have any trouble because the motion of the pallets is pretty slow anyway, so there shouldn't be any wrecks or any problems like that. And plus, I don't let the pallets enter the intersection unless the path through is clear, unless the rotary conveyors are rotated in the right orientation. But when should this come on? Well, this is a green timer for one direction. It should come on when the red timer for the opposite direction comes on. So when does the red timer for the opposite direction come on? It comes on when yellow 1 timer is not done. I will use the same condition here. Now, I could have put an OR around this, and just like I did with the other outputs, and set up this timer on the same rung as rung number 2, but I've chosen to do it this way instead. Good, bad, ugly, I don't know. It'll work. Okay? And now this will automatically be reset every time that this other whole house of cards falls, right? Because this yellow timer will eventually be done, which will cause the green timer in the cross direction to reset. So now I have a timer that runs when red begins on the other side. Now notice it doesn't run as long, right? The red timer runs for 30 seconds. This cross green timer only runs for 25. So let me figure out the logic for the green cross direction. Well, let's see. When should it be on? Well, obviously these are the wrong conditions. Let me start by getting rid of this one. And I don't want to reference green 1 timer. I want green 2 timer, which is timer 4. And of course I forgot to name it, so let me name it. So we'll edit, and let's see. I'll call this one green 3 timer. because that's really what it is. It's for timing the green lamp in the cross direction. You could refer to lamp 3 or 4. In fact, notice I'm driving both of them. But I'm timing both of them. There's no point in having a separate timer for the other light. They're just both on at the same time. So when green 3 timer is not done, the green lamp should be on. And that makes sense, right? Because the green 3 timer is going to start running at the very beginning of the cycle and then won't reset until the end of the cycle. So that should work. That should turn on the green lamps for the right amount of time. But as soon as that timer's done, well then the yellow lamp should come on. So I guess that's our condition, right? T4. When green 3 timer is done, then turn on the yellow lamp. The only problem is that yellow lamp should not stay on the whole time, right? So when should that yellow lamp go out? Well, it needs to correspond to red in the original direction, the master direction. When that red 1 timer is done, really what happens during this red 1 timer here is green in the cross direction has to turn on and yellow in the cross direction has to turn on. But once this red timer is done, well, then it's time for yellow to turn off. So I've got an AND condition here. Or I need an AND condition. So let me insert a column before the cursor. And I guess to keep everything lined up, I'm going to cut this, move it over here. You can't just drag and drop, which is unfortunate. But I need for timer 1, which is the red timer in the original direction, to not be done. So as long as the green timer in the cross direction is done and the red timer in the original direction is not done, then yellow should be on. Alright, so I think that's it. I am not going to, I guess I'll go ahead and save it because I've already given it a new name. I need to download it to the PLC, so let's do that. So there we go. Transfer is complete, put it in run mode, and let's see if we have some nice lamps. Let's see. Well, I guess I need to go up just a little bit, not that much. Let's zoom out just a touch. So we can see red in the original direction, and if I move over just a little bit, we might be able to see all of them, especially if I bring it to the front. There we go, we can see all. Well, not quite. There we go. Okay, so green in the original direction, the master direction, red in the cross direction, that's good. Let's see, we want to see yellow in the original or master direction next. I guess we can scroll up and watch our timers run. Give us something to do. We're at 17, 18 seconds on green in the original direction or the master direction. 23, 24, 25, yellow, there we go. Red in the cross direction, that's good. And we've got red in the original direction, green in the cross direction. So now notice that our green timer for the cross direction is running. We've got a little ways to go, about 15 seconds. We've got red in the original direction, green in the cross direction. We're at 17 seconds. Once green timer in the cross direction runs out, the yellow lamp should come on in the cross direction. There they are, yellow in the cross directions. And notice green keeps running. We went to red then after 5 seconds and yellow. Good. So it's working. Now we're ready to turn on some traffic. Let's see if these changing signals can successfully control traffic. So what I'm going to do is try to make this go full screen. There we go. And let's get an overhead view of everything. Looks like I'll have to zoom in a bit. Get a nice overhead view, sort of where we began. Rotate it nicely. There we are. So we may not be able to see pallets or cars coming in at the top and the bottom, but this should be good. That way we've got, I guess it would help if I press the button. Let's see, I've just gotten into position. Now that's okay. We'll go down. We'll go over. I should be able to press it from here. I'd like you to see that the lamps are on properly. Yeah, we're in stop mode, so we'll hit start, and there we are. So let's get an overhead view as quickly as we can. I'll turn the sound down because it can be pretty annoying. So we've got one car that successfully went through the intersection. You know, if I zoom out and then rotate down a bit, we may be able to see the signals. Okay, there we are, we're simulating. So we've got a car here waiting to go, but I didn't let them go in on a yellow light. That's why it didn't come in. Got one here waiting to go, but this is not rotated. Now it's possible that my counters are off. Looks like traffic this way is flowing all right. Let's have a look at the counters and see what's going on. So I'll go into the traffic simulation subroutine. Yeah, we got 4, 5, 4. You can count 1. Let's look at all the counters. Yeah, we've got a -1 here in one of our counts and a 2. So here's what I recommend you do. If you struggle with this, just reset it. Reset both at the same time. So just go down and get ready and just reset this simulator. Whoop. Reset the simulator. That'll get rid of all your palettes, and then hit the reset button also. And what that'll do is clear all the counters. And actually this is a pretty decent view. So the direction we're looking at is direction 1 going into the distance. Direction 2 is coming towards us, almost. You'll notice the cross direction of 3 on the right and 4 on the left are waiting. We're in run mode. You can see the lamp right here. We've got a green lamp on the master direction. And so traffic just keeps flowing. They will keep entering the intersection until we get yellow. So there's yellow. So the ones that saw yellow before they entered the intersection did not enter. You see the pallets have to clear completely before the tables turn to allow traffic in the cross direction to flow. And of course there are counters that are keeping track of how many boxes are still in the center. But we've got green in the cross direction for both traffic flows. Now we've got yellow, so they stop entering. And I'm sure it'll mess up before too long. It always does. One thing that can happen is that pallets can end up close to the turntables, still technically not in the intersection, because there's a certain amount of space between the sensors where they stop and the sensor where they enter the intersection officially. There's actually sensors on the turntables themselves. Anyway, there's a distance there, and probably it'll happen on direction 1 right now. See how it's trying to get into the intersection, yet it's trying not to go. That one might go through, it might not. Yep, it didn't. It messed up. And that will tend to mess up the cross direction. And of course, since it didn't go all the way through, you see that the cross direction for 3 didn't open up. And so this is where you can have some fun. You can start just yanking pallets off of the conveyor line. Unfortunately, here we have to reset everything. So, as I said, the simulator is not ideal. It is not perfect by any stretch of the imagination, but it will allow you to start using timers to drive things. And like I said, this is a classic problem. It's a traffic signal problem because it's based on time. You could have things that are even more complicated. You could include and simulate a crosswalk request, which, if you think about it, it's kind of scary. There's no sensors for human crosswalk people, are there? There's just warnings to tell you as a human being, hey, dummy, get out of the intersection if you're in it, right? We're about to change the lights, and you don't want to be a roadkill, right? So overall, though, this is working. This is all I really expect you to do. Please don't just copy what I've done. Please watch the video, try to understand it, and then try to recreate it, because where you'll really learn how to use timers is in the challenge of creating it yourself. You'll notice I did this with 4. You can actually do it with 6. You could set up a whole independent side. You just have to start them both on the same time reference. Of course, they can't be sequenced exactly the same. You can't have green both directions. I remember back in my younger years, I didn't watch a lot of Beavis and Butthead, but I watched a little bit of them. If you don't know who they are, I wouldn't recommend watching them with children, and they're fairly brain dead, honestly. But they're sort of the precursors to probably South Park and some of the other very irreverent cartoon shows. Anyway, there was one movie they had, and there was a natural disaster, and of course they're both idiots, and so their teacher, who's always a do-gooder, is trying to help direct traffic because the signals are out, and of course there's a potential for wrecks. So he sees them come along. He has other things he needs to do. He calls them over and says, "Here, direct traffic." So they're one standing in one direction, one standing in the cross direction, and they're both just motioning people to come on. That's probably the best part of the movie, in my opinion. Beyond that, I don't remember much of anything else. It's the only part that really got a laugh out of me. So anyway, we wouldn't want both timer sets to start at the same time with 6 timers and have green on at the same time. You don't want the cross direction and the original direction to allow traffic at the same time. It's not possible here, obviously. So that's what you're supposed to do. Oh, by the way, you can do this with one timer, but you have to use comparison instructions. I'll leave that to you as a challenge. And I don't want that as your solution. I want you to use cascaded timers for this lab. But do see if you can figure out how to do it. And I will post a solution to that as well. It's pretty easy. And it's actually more flexible than this because you can have some overlap with the reds very easily. You only need one timer, which makes it simple. And your conditions are fairly straightforward as well. But you have to use comparison instructions instead of bit instructions. Looks like direction 3 is going to give us a problem this time, this palette. And let's see, it's never going to make it through the intersection. Let me see if I can force it to make it through the intersection. I'll just drop it. Oh, right about there. That way it triggers that sensor and maybe allows it to go. Let's see if that reset the counter in direction 3. Is direction 3 a 0? Nope, it's not. It's still a 1. So direction 3 won't go anymore. We'd have to do a reset here. No, it did go. Okay. Let's see. Looks like it's off by 1 count, so I'm actually a little bit surprised that it's working. Let's see if the count for direction 3, which is going from right to left across our view, let's see if it ever goes down to 0 when the last pallet comes through. Let's see, there's one drop, here's another drop. So as far as it's concerned, there's still a pallet in the intersection. And what that will do is prevent the turntables from turning properly for direction 2. Yeah, there it is. Now obviously we could go in here and correct it. We can override this value, but there's not really much of a point. And you'll notice a pallet just somehow got caught there, and so the signal doesn't fall. It doesn't see a falling edge like it should on direction 1, and it thinks there's 2 extra pallets in there. So again, not a perfect simulation, but this is not the part you have to worry about anyway. You have to write the main ladder portion where you're timing the lights, and that's your challenge for this lab.